Alright, so these are the examples for 3-2. So here we go. It says in the figure, measure of angle 9 is 80 and measure of angle 5 is 68. So I'm going to go ahead and label my picture. Angle 9 is 80 and angle 5 is 68. Find the measure of each angle. Tell which postulate or theorems you used. So the first one is angle 12. So here is angle 12. And what you will notice is that angle 12 and angle 9, those form a linear pair. And from your supplements theorem, we know that those two angles add up to 180 degrees. So if this is 80 degrees, angle 12 will be 100 degrees. And again, this is your supplements theorem. And we know angle 9 and angle 12 form a linear pair. Okay, angle 4. So that's this one right here. Okay, so whenever you're looking at these, we're having to look at the two lines that are parallel. So here's my two lines that are parallel, and P is my transversal. So if you look at the relationship between angle 4 and angle 12, those are corresponding. And you know from your corresponding angle postulate that these two angles are congruent. So if angle 12 is 100 degrees, then we know angle 4 is 100 degrees. And again, that's your corresponding angle postulate. And the two angles we're talking about are angle 4 and angle 12 are corresponding angles. Okay, last one like this. Angle number 7. So we're looking at this angle right here. Well, if you notice, angle 5 and angle 7, those are your bow tie angles. Okay, these right here are your vertical angles. So what we know is that vertical angles are congruent. So if angle 5 is 68 degrees, then we know angle 7 is going to be 68 degrees. And that is from your vertical angle theorem. So vertical angle theorem. And again, we're just going to write down which two angles we're talking about. And that is angle 5 and angle 7 are vertical angles. One thing I do want to mention before we move on to the next part is you cannot have a relationship with angle 4 and angle 5, because if you look at these two lines that they lie on, line P and line Q, those are not parallel. And so the only way these angle relationships work is that they have to lie on these parallel lines. So when you look at 4 and 5, you can't say that those are your same side interior angles, because like I said, these two lines are not parallel. All right, let's go to the last little section here. It says find the value of the variable in each figure and then explain your reasoning. So what I'm going to do here is I'm going to kind of extend these lines out so that we have just kind of a better picture here. Okay, so there's my two parallel lines. Here's my transversal. All right, so the first thing I'm going to do is I see that I have this angle that has an x in it, and I have this angle that has an x in it. So I got to figure out what relationship do I have between these two angles. And if you notice, they are in the same spot. One's just up here, and one's down below. Okay, so if you look at like your four corners to know if they're corresponding, they have to be in the same area of those four corners. So both of these are in the top right, so they're corresponding angles. So the first thing I'm going to use is my corresponding angle postulate. So there we go, postulate. and that's to find x. So my corresponding angle postulate tells me that these two angles, 5x minus 5, is equal to 4x plus 10. So we're going to go ahead and we're going to solve for x. Subtract 4x from both sides, you have x is equal to, add the 5 over here, 10 plus 5 is 15. The next relationship that I see is there's two things that you can do. You can use 5x minus 5 and 6y minus 4 because these two right here lie on a line. So that's your linear pair. Or if you wanted to use your consecutive interior angles theorem, your same side interior angles, you could do the same thing and get the same answer. I'm going to go ahead and use my supplements theorem. So that's this second one, supplements theorem. And what that tells me is I have two angles. They lie on the same line. They form a linear pair. And so the sum of these two angles has to be 180 degrees. So 5x minus 5 plus 6y minus 4 is equal to 180 degrees. And I now know x, so we're going to plug that in right here. So 5 times 15 minus 5 plus 6y minus 4 is equal to 180 degrees. We can go ahead and simplify. 5 times 15 is 75. So minus 5 plus 6y minus 4 equals 180 degrees. Combine our like terms, so we end up with 66 plus 6y is equal to 180 degrees. Subtract 66, so we have 180 is equal to 114. Divide both sides by 6, and we get y is equal to 19. Double check to make sure that that's all that they want. And it says here just find the value of the variables in each figure. Well, we found x, we found y. Those are the only variables in the figure, so we are done with that problem. Just be sure that you do explain what postulate or theorem that you choose to use to find your variables. Alright, last one. Find the value of the variable or variables in each figure. Explain your reasoning. So this one we have three variables we have to find, x, y, and z. So the first thing that I'm going to do is I notice that I have all three of these lying on a line. Now remember, if you have more than two, you cannot say this is a linear pair. It's not a linear pair. Linear pair, pair means two. You have three angles here that all lie on the same line. So I know by angle addition postulate that 2x plus 90 plus x is equal to 180 degrees. So we're going to go ahead and we're going to solve for x. So I have 3x plus 90 is equal to 180. So 3x is equal to 90. So x is equal to 30. Okay. Next thing that I can see is these are my parallel lines. So this right here is a transversal. Okay, and since that's a transversal, I have these two angles form a relationship. They're on the inside, so they're interior, and they're on the opposite side of this transversal. So this is my alternate interior angle theorem. And what that theorem tells me is that these two angles are equal to each other. They are congruent. Well, I already know over here x equals 30, so 2y is equal to 30. So I can figure out that y is equal to 15. Okay, and the last thing that I have, there's a couple ways, there's more than one way you could do this. I see right here that I have 2y and z. There's two angles, they lie on a line. They form a linear pair. So I'm going to use the supplements theorem. You also can do your same side interior theorem or your consecutive interior angle theorem for x and z. It doesn't matter, you're still going to get the same answer. So I'm going to use my supplements theorem that tells me that if I have a linear pair, I know these two add up to 180. So 2y plus z is equal to 180 degrees. I know y is 15, so 2 times 15 plus z is equal to 180. So 30 plus z is equal to 180. So I have z would equal to 150 degrees. Alright, so there's x, there's y, there's z. I have x, I have y, I have z, and I explained my reasoning by using either certain theorems or postulates.